All right, number 5. I have sines and cosines on the right side. I have tangents on the left. And really, as I'm looking at the sines and cosines, I guess I could factor a difference of squares in the denominator, but I don't really know what else to do there. So I'm going to work with the tangents and change them to sines and cosines and see if I can make some headway that way. So tangent is sine over cosine. And in the denominator, I'm going to go ahead and change that into 1 minus sine squared over cosine. Then in the denominator, I need a common denominator. So I'm going to change that 1 into cosine squared over cosine squared. Go ahead and pause, if you haven't yet, and see if you can get ahead of me now. See if you can combine in the denominator. See if you can get it to look like the other side. There. All right, hopefully you were able to get a couple steps ahead. I'm going to keep going here. My numerator hasn't changed. It's sine over cosine. My denominator has. I can write my whole denominator over cosine squared. And my denominator is cosine squared minus sine squared. So the last problem where we had division like this, complex fraction, I didn't do all of the options for you. So let me talk you through this. Some of you like flip the second and multiply. If you like flip the second and multiply, the denominator is what you're flipping here. If you like grouping, which I do, then I group the top and the bottom become my new numerator, and the middles become my new denominator. If you're comfortable enough to cancel a cosine right now because of this, the way this looks, that is even better. All right. So my new numerator, whether you're flipping the second to multiply or whether you're doing the grouping that I'm doing, your new numerator is sine times cosine squared. And your new denominator is cosine times cosine squared minus sine squared. And your last step here is to cancel a cosine. And then you match the other side of your proof perfectly. Sine cosine divided by cosine squared minus sine squared. That one I think is one of the trickier ones to look at from the beginning because you feel like you should be able to work with the sine cosine side. There are squares and it looks like you should be able to work with it, but there are no identities, and changing sine and cosine into tangents is much harder than changing tangents into sine. Again, keep pausing as you need to. Rewatch any steps that are confusing. Pause and get ahead. Pause and catch up. That's what the videos are